So if you Google Git tutorial, I did it earlier today, and I got about 17 million results. So I'm not going to spend a ton of time on like really specific things with Git. You can Google them anytime you want. There's an awesome manual page. There's actually a Git book that's published for free online. But what I want to talk to you about what it is, kind of from a little bit of a higher level, and why you should care. And I will go through some concrete examples that I think will be useful to you. So what does version control do? There's some really common problems that come up when you're programming, especially when you're programming in a team. Version control is the set of tools that's designed to deal with these problems. So Git is to version control what Notepad is to text editors. It's one of many available tools that all kind of do the same thing, and it just happens to be the most popular thing of its type that's out right now. So these are kind of the specifics. We're gonna talk about tracking change history, branching, and then version changes. So when I say tracking change history, we're going to start by talking about a commit. And a commit is kind of the lowest concept, the smallest concept that everything else builds off of. And I just have it represented as that little dot that's much more bright and cheerful on my phone than it is on that screen. So a commit is a set of changes to one or more files. It has a unique identifier, usually in the form of a hash, and it includes a little bit of data about who made that commit and when. So when you when you take a few changes together, how can we see that? Pretty good. So you can take a bunch of changes that you've made and add them together to make a commit. So here's an example of if you've added a new file, for example, that new feature.py, you can add that and it'll do what's called staging it. And then you can add multiple files, you can make whatever changes you need to make, and then you can commit all of those things as one atomic piece with that git commit, and we're just going to we put a message on it. And it just gives us a little bit of feedback there about, we changed 2 files, we added 9 lines, one of those files was created, things like that. So it kind of tracks all of that for us. And when you add commits together, you kind of build a history over time. So what do you do once you have that history over time built up? I feel like this is a really common problem. When I was a student where I would write something and then it would work one day and then I'd come back to it the next day and it wouldn't work. And I didn't know what I changed that broke it, which was really frustrating. So we can have Git show us what's changed since yesterday. That was another problem when I was a student, was continuing to make changes after having a few too many drinks. Overshooting the Balmer peak by a little bit. So now that I know when I changed something, I can go and I can see what exactly I did change. So there's a lot going on in this picture, but Git colorizes the parts that are important to you. They're pretty washed out on the projector here. But if you look, you can see at the very bottom, it shows where I added one line and I removed another line. And it's that I changed that one line, and I changed just the array indices in that line, which would be pretty much impossible to pick out just by scrolling through that file. You would have no idea. But by comparing it to previous versions of itself, it's really easy to see what actually changed. I'll be posting these slides so you can kind of see these with a little better color reproduction later. And what's great about Git is we can even fix it. Once we know what that problem was, we can do what's called a revert, and we can back that change out. So it actually makes the reverse of that commit. So if your commit is that you added a couple files and removed a couple other files, revert will actually do the opposite of that, which is pretty cool. And it can do that because, again, it has all that history that it needs to know what was there before that you deleted. So sometimes you don't have a good frame of reference for when something broke. You just know that something went wrong. Finding where it went wrong isn't always necessarily the problem. You can track that down to a line of JavaScript, and you might ask, who added that line to my JavaScript file? And Git will tell you. And the command is actually literally its blame. So you can say, who do I blame for this line in this file? Some systems alias it to bless or annotate, but it's been blamed since about 1986. So more often, it's not actually malicious like that. It's more often you need to know why some kind of stupid code is in somewhere where you're finding it. And usually you're wondering why. Why did somebody make this change? Why would somebody write code like this? And with Git, you can actually find out why. So a lot of times it's like, hey, this code is written in this ridiculous way because it's working around a bug in this library that we're using, for example. And maybe you're not using that library anymore. Maybe you're not using that version of it anymore. Maybe that bug has been fixed. So you can learn a lot about every individual line of a program as it evolves over time, which is really cool. Because it shows you who the original author is, you can sometimes talk to that person if they're still available, or at least you can see their thoughts. You can see what they were thinking when they made that change, and that's a reason as well when you're making changes. You're really mindful of what you put in your commit messages, because future you will really appreciate it when you come back to a problem a year later and you don't know why you wrote the code the way you did. Those are some emails. So here's an example like branching and merging. This is another feature. So a lot of times you need multiple people to contribute together to the same project. So those are 2 emails that came in where somebody went through and they added documentation to all the functions in the program, and somebody else went through and they fixed a couple of the bugs that were in the program. And you're going to want to combine those things before you submit it either to your teacher or you submit it to your client or whoever you need to, whoever needs to get that code. I had to deal with this a lot before, and it involved a lot of copying and pasting code around, and hoping against hope that you got things right, because you'll never know if you missed somebody's changes. This is another really common thing. Is anybody doing this right now? We have a new folder every time you make a major change, just in case. You're pretty good. All right, that's impressive. So, if you do this a lot of times what you'll end up with is you're trying to figure out what's different between some of these things, because something that did work, say, after September 25th, stopped working, but something you had working before is no longer working. And trying to figure out the difference between those things and trying to combine those code bases is really hard. It is a lot more work. A lot of times you just end up just giving up on one thing and having to fix it from scratch again. And sometimes you'll get things like we see Mike's feature down at the bottom right, and that's great, but he started from your September 21st branch, and you've made a ton of changes and bug fixes since then, and now you can't get his feature integrated in, which is really frustrating. So if we took these folders and we put them on a timeline, you might see something like this, where you kind of have your master branch, which should always be working locally, and then you have your other folders when you go and you try to do something risky. You're going to make a big change, you're going to fix a bug that you don't really understand, something like that. This is built into Git, it's called branching, and it's built into most source control systems. So every time you copy a folder, or every time you make a branch, it's creating that parallel history to what your current, like your main history is. And there's the Git commands to do it. You're going to create a branch called little feature, and then we're going to check it out, which just tells Git, this is the branch that we're working on right now. And that branch, until you want later, it's going to exist in its own little pocket universe, completely independent from everything else. So make your branch, write some code, like you're a genius. You'll get it right on the first try, I'm sure. And then you've got your feature, and you want to bring it back into your main. And maybe you have a branch from somebody else, anything like that. So you want to merge your branches together. And there's an example of that. It's just git merge, and you say merge into my master branch, this feature branch, and it's going to do it for you automatically, which is really cool. And we can kind of see what the history looks like after that. So the thing is we're going to let Git do the heavy lifting. So instead of you copying and pasting and trying to figure out what comments go where, what fixes go where, Git can figure it out, and it is really smart. It'll look at the line numbers and how they've changed, and look for familiar lines to know, like by reference, where other lines have moved to, things like that, like relative to where other lines are. So it is really smart, and it is really good at this. So something else with Git that's kind of interesting is Git is what's called a distributed version control system, which is different from some older systems. So a lot of older systems, you had to check in with the network machine. If you were sharing your work with other people, everybody had to always talk to the network server all the time, constantly, which was really irritating for a variety of reasons. The biggest one was that you couldn't work when you didn't have a network connection. No working on a plane, no working when the internet is down. You know, they were really frustrating to use like that, and in a lot of cases, they were excruciatingly slow because they had to talk over the network every time they had to do anything. So Git makes you do this extra step. You have to push if you want to. It either runs entirely locally, or anytime you want, you can say push, and that'll push it to a networked machine. And it's like a little bit of extra work compared to some other version control systems, but it saves a ton of time and solves a whole bunch of problems. But if you want to push it to another server, that server is really kind of a pain in the butt to set up and to maintain and to run. So you probably don't want to do it yourself if you can help it. GitHub is kind of what most people are using these days, which is pretty awesome. They'll take care of the entire remote aspect for you. They build a whole bunch of extra stuff on top of Git. They're mostly free as students. Everybody here can get a free GitHub account that's worth about $7 a month.
With the free GitHub student stuff, you also get a free bunch of other stuff like free credit on DigitalOcean for web hosting.
They partnered with Microsoft, they partnered with Amazon. They have what's called an educational pack. And I link to it in the slide as well, which we'll send out. And if you email them from your Go.eu email address, they will heap free stuff down upon you. And they have this terrifying octopus cat hybrid as their mascot, which they seem to think is adorable. So they're awesome, and I'm going to talk a little bit about them. So that change history that I showed earlier, they have a great interface to show it. If you're not super comfortable with command line, they have a great interface to show it. And you can see, you know, finding specific changes and viewing your code and things like that is really easy. If you want to merge two branches together, they have a really clear way, a really clear, you know, point-and-click interface to do that. And it shows you exactly what's getting merged, and you can do things like one of the features that's built on top is this code review, where if you were working with a team, somebody could go in and they could comment and they could say, hey, this change that you're making is wrong, or if you should change it to this instead or something like that. And they provide a really awesome interface to do that. And again, this is a log of commits over time, just to kind of show that history of your repository and of your code. So before I go into the takeaways, I'm just going to talk a little bit about GitHub as a portfolio piece. We had some questions asked about that in between talks and things like that. And I really do think that it is like one of the best places that anybody can put their code. If you're working on code, just create a GitHub account. It's free for students, even if you have to pay for it. I pay for one, I pay $7 a month. And all that gives you is private repositories, because I have a couple of repositories with code that I don't want to share with the world, with things like my home automation server and things like that. But an unlimited number of public-facing repositories you can get for free. And as a student, I think they give you 5. I think they give you 5 private ones for free. And they're awesome. If you want to build a portfolio, if you look at mine, my GitHub username is Greg here. And you can take a look. And I have school assignments. I have little hobby projects that I've done. There's all kinds of little bits on there. And I have absolutely walked through that for interviews when I was being interviewed. And I have walked through other people's code on their GitHub when we were interviewing them. And it is incredibly useful. It lets you talk about code that you're familiar with, and it lets interviewers see code that you've written. And you can even, if you haven't a long enough running history, you can learn a lot about how somebody thinks by looking at their commit log. And by seeing, you know, did they organize these commits very well? Did they do this all at once, or are they working on it over a long period of time? There's a lot you can learn from that. So I think it's incredibly valuable, and I would absolutely encourage everybody to start using it. It's also a great way to teach yourself Git. They have really helpful information on the website and how-tos with screenshots and everything like that. So they're really awesome for that. So to give like a really quick crash course in Git as the takeaway here, this is the command line interface. There are also other interfaces. We've used one called SourceTree, which was really good. GitHub has a Windows and a Linux application as well. This is the Linux kind of the default version. That's actually on my MacBook. And you know, so the bolded commands are Git commands. So I'm just initializing a new Git repository where there wasn't one before. I'm creating a new file and I'm adding it, and then I'm committing that single file. with just a message out that first file. And it got a little squished there, but we can see I have my little init dot, and then I have my first init and my history dot. Then I make a branch because I realized, I look back at this, and I realized that I spelled first wrong when I was doing it. So I go and I say I want to fix that. So I make a branch and I check it out. And I delete that file, and I recreate it, and I re-add it, and I commit it, and I say I'm fixing bugs. And now that is existing in a parallel timeline for my master branch. So I want to merge that back into my master branch. So I switch over to my master branch, and I say merge fix, and that's the name of that branch. So I'm going to merge it into my current branch, and we come back and collapse back to that single timeline. And this is just a really quick example of if you want to host it on GitHub, you can say, okay, you know what? I'm ready now to show the world my great work. So you can say it's a bit of a long command. Like I said, if you Google, you'll find all these commands. But I'm saying I'm going to add a remote server for this. I'm going to call it GitHub. And there's the string, like git@github.com. And GitHub, when you create a project on GitHub, they'll give that to you. They'll say, when you want to do this remotely, here's the string you use. And then I push my branch into that, and now that's available to the whole world. Unless it's a private repo, in which case it's available to myself and whoever I choose. There's some really advanced stuff with Git that I didn't talk about. You can rewrite your timeline. You have situations where you want to merge something and it can't merge because even though Git is really smart at figuring it out, sometimes it just can't do it. It just can't figure it out automatically, and you have to do that by hand. I could talk about Git literally all day long, but I feel like until you start using it and start getting some of these problems, it's not going to make any sense. So, yeah, the best way to use it is just to start using it. I've used it for text files, I've used it for source code, I've used it for video games. It's great for all kinds of stuff. And once you get comfortable with the basics of just that add, commit, branch, merge, then any of the harder stuff will be a lot easier once you understand that kind of basic stuff. Any other questions? Any questions?
How do you manually merge something if Git fails?
Sorry?
How do you manually merge something if Git fails?
So if Git fails to automatically merge something for you, what it'll do is it'll leave things in a kind of in-between state, and it'll take the two files, and where it failed to merge them, it will have two blocks of code. And one is from the original, and one is from the branch, and they have these really clear markers around, and then you basically choose either which one you want, and you can delete the other one, or you combine the two of them manually. Usually that happens when two people change the same lines at the same time, and then there isn't a correct way to do that, right? It has to be done manually. Anybody else? So the question is, what would you do to make your Git repository more appealing to employers? So there's a few things. Having like well-polished conventions. So on GitHub in particular, there's a readme.md convention, which is you can put a text file in your repository in this markdown style format. It's kind of like really simplified HTML. And you can describe your project. And you can make links, and you can embed images, and when you load up a GitHub repository, that markdown will be rendered right on the bottom of the repository, which is really helpful and useful to see. The other thing is when you look at your commit log, make sure that it's not ridiculous. Hopefully, you don't have a lot of drunk coding commits like I did. And as you learn more advanced Git, you can kind of rewrite that history. And you can, rather than just revert those commits, you can actually pretend like they never happened. So some things like that to kind of clean up, and sometimes you don't have to do that. Sometimes it's just a matter of rewording some of your commits, right? You were getting frustrated and you committed 10 things one after another, trying to fix this problem, and then you finally got it on the 10th try. You can squash those commits. You can take all 10 of those commits and you can make them look like one commit, and you can write the message for that, like, yeah, I got it on the first try, or something like that, right? So there's some cleanup that you can do with that. Documentation is a good way to show like well-commented code and things like that. Like a lot of languages now have formatters and linters. So like Python, Go, Dart, a lot of things like that. They have programs that will tell you if your code is well formatted. So in Python, for example, if you have spaces in certain, in between certain operators and things like that, they're like, well, that's not how it should look. You should, and maybe some languages are very picky about should you have a new line after a curly brace on an if or on a function definition or anything like that. Some languages don't care. If your language cares, run one of those linters, run one of those formatters, and make sure that your code looks pretty. It sounds kind of ridiculous, but when you're just somebody kind of looking at it at a glance, it's meaningful. So there's a couple. Having other collaborators is also really nice. If you can show that you have something that you're actually working on with other people, that can be really good too. And jumping in on an open source project or something like that, if you want to show your Git, if you go to somebody's GitHub, you can usually see if they're working on an open source project. They'll have a local fork, or you can look through their commits and see where they've committed to all these different places. And that's really good too, just to show that you're using the actual, distributed and local user features of the language. You can work with other people like that too.
If you're using Git for a team project, is it possible to lock files so that you're the one working on them and nobody else?
So if you're using Git for a team project, is it possible to lock files so nobody else can work on them?
Yeah, like
No, and that's very intentional because that's how a lot of older systems used to work, and it caused a lot of frustration where files would get left in a locked state and things like that. What the convention today usually is. Yeah. So Git uses an optimistic model rather than a pessimistic model in that sense. So the gist of it is, rather than pessimistically lock it, assuming that problems are going to occur, it optimistically leaves it unlocked, and then right at the last second, right as you try to make your merge, it'll try to do the merge. And if it can't do it, that's when you get into trouble. But there's no need to lock it ahead of time. It's just your responsibility, basically, when you go to merge, to make sure it does merge on. And I can say from experience that that works really, really well.
So every branch that we copy is
Anybody else? Okay, well, I'm going to hang out a little longer, and I'm going to drink my drink, and feel free to come over and ask me any questions that you might think of. Thanks for having me.